this episode, we're going to be doing another lesson on NetworkLessons.com, and it's going to be a lesson on OSPF hello and dead interval timers. OSPF uses hello packets and two timers to check if the neighbor is still alive or not. One of these is the hello interval. This defines how often we'll send that hello packet, and we have a dead interval. This defines how long we should wait for hello packets before we declare a neighbor to be dead. The hello and dead interval values can be different depending on OSPF network types. On Ethernet interfaces, you will see a 10-second hello interval and a 40-second dead interval. So we have this topology that I copied over to GNS3 already, and let's go ahead and configure these interfaces. FA00, give that an IP address of 192.168.12.1, the subnet mask of /24, do no shut, router 3. It's taking a bit of time, kind of laggy. Oh, there it is. All right, we'll configure FA00 with an IP address of 192.168.12.2. We'll do a no shut, and going back to R1, we'll configure OSPF now. Router OSPF, process ID number 1. We'll advertise out 192.168.12.0. Give this a wildcard mask of /24, area 0, and okay, it wants us to do a show command, show IP OSPF interface FA00. If I do it without any pipe, okay, I see why they need the pipe now. So include interval. All right, so what it says is that the hello timer is configured at 10, dead is at 40, and wait is at 40, and retransmit is at 5. So if we shut down FA00, after it shuts down, oh, sorry, I forgot to configure R3. I didn't see that he wrote this here, R1 and R2. All right, so router OSPF 1, advertise this network out, 68.12.0. 2.5, area 0. And going back to router 1, we enter FA00, and if we shut down, what are we going to get? What are we going to get? Over R2, we should get this message, but I don't know if you have to turn debug on in order to see this message, so we'll find out. I suppose it'll take up to 40 seconds. All right, there it is. So it says that this is an neighbor R1 on fast Ethernet 00 went from full to down, and now the neighbor is considered down because of a dead timer expired error or flag or whatever you want to call it. Alright, so going back to R1, we will do a no shut, turn it back up. R2 will keep sending traffic to R1 while the dead timer is expiring. To speed up the process, we can play with timers. So if we go to interface, I think we're already there, so IP OSPF hello interval, so 1, and do a, oops, sorry, then IP OSPF dead timer, or dead interval, 3. If we go over here, we'll do the same thing. OSPF hello interval 1, OSPF dead interval 3. Then we'll do the show command. We'll see that the hello timer changed to 1 second, dead to 3, and wait is also at 3. We can reduce the dead timer to 1 second if you use the IP OSPF dead interval minimal command. Then you can also specify the hello interval there. So IP OSPF dead interval minimal hello multiplier, number of hellos sent within 1 second. Okay. So let's do that. T int fa00 IP OSPF dead interval minimal with a hello multiplier of 3. So if I do that there, I have to do it at R3. R3 went down because the dead timer it expired. And I got some weird text message. What is this? Oh. Anyway, let's go to R3 and okay, do IP OSPF dead interval at a minimum. And the multiplier is 3. And we'll do an end, and we'll see what this says. So it looks like the hello timer is set at 333 milliseconds now, and the dead timer is 1. So each 333 milliseconds we'll send a hello packet. If we don't receive any within a second, then we will declare the neighbor dead. Our routers will now react quickly when they don't see a hello packet in time. It's also possible to reduce failover times even more using something called BFD. This protocol runs independent from routing protocols, and it's used to detect link failures between 2 endpoints. It's used often on links that don't offer any failure detection, like Ethernet. We'll cover this in another lesson. I suppose that's it. Thank you for watching. I will start another lesson on OSPF router IDs.